Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our today's chemistry class, and today I will discuss about oxidation number. And in this video we are going to learn how to figure out the oxidation numbers for the different elements in a chemical compound. And now we have to know about what is oxidation number. Oxidation number is a number assigned to an element in a chemical combination which represents the number of electrons lost or gained by an atom of that element in the compound. And the loss of electron is represented by a positive sign, and the gain of electron is represented by a negative sign. And the oxidation number often referred to as oxidation state. Okay, and and there are the rules that we are going to use to figure out the oxidation numbers. And the oxidation numbers, look at this is elements, elemental molecules, and elements, metal atoms and non-metal atoms. And here the above the molecules or atoms, I have written and here the oxidation number above each one of these elements. Okay, and for all these elements the oxidation number is 0, and this is our first rule. Okay, and the first rule is this: an element by itself always has an oxidation number 0. Okay, and it means that there are a lot of chemical substances like that, this and substances that have just one element. That element is not combined with any other elements, and that's why what calling an element by itself. Okay, that's why these elements is calling an element by itself. So that is something, this chlorine, that means this chlorine, just chlorine, nothing else, and this sodium, just sodium, nothing else. And similarly this is definitely true for all these elemental atoms and molecules. And so the first rule that you need to know, and you need to keep in mind, is that the oxidation state of any pure element is always 0. And the next rule, the second rule is about monoatomic ions. Okay, these are ions that are made of only one. Look at this. These ions are monoatomic ions. So like this for monoatomic ions, and their oxidation number is the same as their ion charge. Okay, this is the rule. Okay, their oxidation number is the same as their ion charge. So for sodium, here for sodium plus ion, sodium plus ion, its oxidation number is going to be +1. Okay, and for sulfur 2 minus ion, then the oxidation number is going to be -2. And for nitrogen, similarly, nitrogen 3 minus ion, this is -3. And for magnesium 2 plus ion, positive 2 positive ion, and it will be +2. Okay, and you have to keep this in mind when we write the oxidation numbers. Okay, when we write the oxidation numbers, then the sign first. Okay, the sign comes first. That means plus minus. We have to put plus minus at first in front of the number. Okay, and this is the opposite of how we write the ionic charges. Look at these charges. Okay, this is completely opposite. For to write the ionic charges, we put number first, then the my plus minus sign after. Okay, but for oxidation number, we have to put the sign plus minus or minus in front of the number. Okay, and the so now go for next rules, and after and we explain these rules using some examples. Okay, and our first example uh, is potassium chloride. Okay, this potassium chloride and ionic salt, and we want to figure out the oxidation numbers of the elements in the compound. Okay, here potassium and chlorine is present, and let's take a look at our rules. Okay, and here potassium is in the column. At first we have to look at periodic table. Okay, and Mm, in this periodic table, you can see potassium is in this column in the periodic table. It's in group 1. So there is this rule, this number 3. Okay, number 3, that the rules is that the elements in group 1 are always plus 1 oxidation state. Okay, the elements in group 1 has always plus 1 oxidation state, and so that the potassium's oxidation number is plus 1. Okay, we put plus 1 here, and then we have now chlorine here. Okay, with potassium, and that is one of the halogens. Okay, chlorine is one of the halogens, and we for halogens we have rules here. This is number 6, number 5, and the halogens have usually minus 1 oxidation number, and positive, sometimes they positive with only oxygen. Okay, they can use positive oxidation number only with oxygen. And now I want to use this to show you another rule. Okay, this rule, that is the rule, the sum of the oxidation numbers, for a neutral compound and equals 0. Okay, the sum of oxidation numbers for a neutral compound 0. We need this formula now, and for chlorine we use minus 1. I put it this. Okay, plus 1 minus 1, and potassium chloride is a neutral compound, and here it does not have a charge after. Okay, we doesn't see any charge around this, and that means the sum of these oxidation numbers is going to equal 0. This is 0. Okay, that means plus 1 minus 1 cancelled out equals to 0, and that means this rule is definitely true. Okay, and we'll use this is the rule. This is very important rule. We will use this rule later on when we do other examples, but now for now just keep that in mind. The sum of oxidation numbers for a neutral compound should always equal 0. And now for our next compound, which is magnesium oxide. Okay, and magnesium, for magnesium oxide, magnesium is in this column. Okay, in this column, along this in the periodic table group 2. Okay, group 2 elements are, and for group 2 elements we have a rule, the rule number 4. Group 2 elements are always plus 2. Okay, group 2 elements are always group 2 elements have always plus 2 oxidation state or oxidation number. So there is oxygen, we put this plus 2 here. Okay, above the magnesium atom, and now there is the oxygen. We have oxygen, and we have a rule for oxygen here, the number 7. Okay, and oxygen is usually minus 2 in oxides, normal oxides. Okay, minus 2 for oxides, and it is also used minus 1 and oxidation number in peroxides. Okay, and peroxides, and very common peroxide is H2O2. Okay, H2O2, hydrogen peroxide is the most common peroxide, and sometimes it can use minus half in superoxides. Okay, and I will discuss about peroxides and superoxides in our next class. Okay, and now this is the oxide. Okay, so for this compound, and oxygen use minus 2 oxidation state. Okay, and now we know this rule, the sum of, for any neutral compound, the sum of the oxidation states numbers are equals 0, then we put 0. Okay, and so the magnesium oxidation state of magnesium is plus 2. The oxidation state of oxygen in magnesium oxide is minus 2. And for we know that the for whole magnesium oxide, the oxidation state is oxidation number is 0. And now our next compound, which is ammonia, and there is not any information, any rule about the nitrogen. Okay, nitrogen in these rules. Okay, and for nitrogen there is no rules or no informations, so we will have to figure out its oxidation number using what we do know. Okay, and here we have got hydrogen. Okay, hydrogen with this non-metal nitrogen, and there is a rule for hydrogen, number 6, hydrogen. Okay, and hydrogen is plus 1 with non-metals, and minus 1 with metals. Okay, when bonded to a hydrogen, when bonded to a metal, hydrogen will have an oxidation state of minus 1, and to determine the oxidation number, the key point is electronegativity. Always the key point is electronegativity. Hydrogen is more electronegative than most metals. Okay, and hydrogen is more electronegative than most metals, and that's why it bears a negative charge uh, negative charge with metals. But hydrogen is usually less electronegative than non-metals. Okay, here nitrogen is a non-metal than most non-metals, and that's why there is a positive charge. Okay, and positive charge, there is a positive charge created. So typically the elements that is more electronegative eh, is the one that usually carries the negative charge. Okay, more electronegative elements carries the negative charge, and in any compound. Okay, and now nitrogen is a non-metal, which means hydrogen is going to have a plus charge. Okay, it means that with non-metal it use plus 1 charge, and but there are 3 hydrogen atoms. Okay, there are 3 hydrogen atoms, each one of them has a +1 charge. Okay, +1 oxidation number. Okay, so what we have to do now, we have to multiply this +1 times 3. Okay, we have to multiply this +1 and times 3, and we get a +3. Okay, and we don't see any charge here around the ammonia, so whatever nitrogen, so we consider it as a neutral atom. Ammonia is a neutral atom, so the oxidation state for whole ammonia is equal to 0. Okay, we write it 0 here. Okay, now whatever nitrogen's oxidation number here, it needs to add together with hydrogen's oxidation number +3. Okay, to make it 0. Okay, to make 0, and this that means the nitrogen has to be -3. The nitrogen has to be -3 to get the 0 oxidation number 0 for neutral ammonia, and that means here only one nitrogen atom is used, and that means the oxidation state of nitrogen is -3, and if in ammonia the hydrogen use +1 oxidation state. And now our next compound, our next compound is zinc hydride. Okay, and our next compound is zinc hydride, metal hydride. Okay, and there is also for zinc, there is not any information, not any rules about zinc, and so we will have to find out its oxidation number, zinc's oxidation number, and using the known informations. Okay, and here we have also got the hydrogen atoms with zinc, and there is the rule, and in for this here hydrogen with metals. Okay, that's why hydrogen uses -1 charge. Okay, -1 oxidation state. Okay, -1 oxidation number. But we put this -1, and here we have a 2 hydrogen atom in zinc. Okay, we have two we have 2 hydrogen atom in zinc hydride, so we have to multiply this -1 times 2. Okay, times 2, and we get -2 charge. Okay, -2 oxidation state, and this is the oxidation number of these 2 oxidation state of these 2 hydrogen, and now uh, uh, whatever, and also zinc hydride is a neutral compound, and that's why the sum of the oxidation numbers of for a neutral compound will be 0. Okay, we put here 0. Okay, yeah, and now whatever the zinc's oxidation number but here is needed to add together with these hydrogens -2 oxidation state to make it 0. Okay, to make 0, and so zinc so zinc here zinc has to be a +2. Okay, to make it 0. Okay, +2 -2 is equal to 0, and so we can say the oxidation state of zinc is +2. Okay, and always you have to Keep in mind this information, and plus and minus sign is uh, putting in front of the numbers to write the oxidation number. Now, our next problem. Okay, this is a polyatomic ion. Okay, polyatomic ions. Okay, bromine and oxygen makes ions, and this bromate ion contains one minus charge. Okay, one minus charge, and bromine is one of the halogens, and the rule for halogens is they are usually minus one. Okay, this is the rules for group 17 halogen groups, and they usually use minus 1, only positive with oxygen. Okay, and now in that case we have to observe the case, and bromine is one of the halogens. The rule for the halogens is they are usually minus 1, and but they are positive with oxygen. So for this bromine, I am not going to put minus 1 in here, okay, because it's with oxygen. Okay, and so let's go to oxygen now. Go for oxygen, and for oxygen is usually minus 2 in oxides, and so let me put that here minus 2. Okay, we put minus 2 here, and now we have 3 oxygens, so that's going to be times 3. Okay, and we get minus 6. Okay, minus 6 oxidation state for total 3 oxygen, and now whatever bromines and the polyatomic ions ion contains bears minus charge, one minus charge, so we have to put here minus 1. Okay, we have to put here minus 1 for the whole bromate ion. Okay, polyatomic ion, and now whatever bromine's oxidation number here is needed to add with this oxygens, 3 oxygens oxidation number with this minus 6 to make it minus 1. Okay, and this number is plus 5. Okay, plus 5 minus 6 is equal to minus 1. So we can say easily the oxidation state of bromine here in bromate ion is plus 5. Okay, and our next example. Okay, now we could solve another example, but will apply alternate method. Okay, very easy method. This is mentioned in your textbook, and for this process let's suppose the oxidation number of the atom in a compound or polyatomic ion that is to be determined is X. Okay, we have to suppose the oxidation number, unknown oxidation number is X, and yeah, let's find out the oxidation state of vanadium in a compound vanadium oxide. This is the formula of vanadium oxide. Okay, we have to find out the oxidation state of vanadium, and so whenever you hear the word oxide, this is vanadium oxide. Oxygen has the minus 2 charge. Okay, and now we have to write an equation for vanadium oxide. Okay, like that. We have 2 vanadium atom, and we have 5 oxygen atom in it, and yeah, then and 2 vanadium oxide and 5 oxygen atom with a net charge is equal to 0. Okay, and now suppose the oxidation number of vanadium is X, then X, then and each oxygen atom has, we can and convert this equation, we can write this equation like that using oxidation number like that. Okay, here two number of atoms of vanadium atoms, and x is the unknown oxidation state of vanadium, and number of oxygen atoms 5, and this 5 times minus 2, and is equal to the whole oxidation number of vanadium oxide, which is 0 for any neutral compound, and vanadium oxide is the neutral compound. And now our manual mathematical problem, mathematically we can solve this. 2x minus 1 is equal to 0. Then we will found we have found x is equal to plus 5. Okay, that means for in vanadium oxide, the oxidation state of vanadium is minus 5. This is an alternate method, and you have to use you have to use this method for your CQ. Okay, and and in your CQ, you have to answer. You will have to answer this type of question. Then you can use this procedure. Okay, and this procedure is shown in your textbook. Now our next problem, and this problem is now I have two more problems, and now have two more examples for you. These two examples can make you confused. One is boron chloride, boron trichloride, and another is iodine penta bromide, and this is boron trichloride, and find out the oxidation state of every element in this boron trichloride. Okay, you have to find out, and we have to find out. And so most we know, most halogens like chlorine, bromine, and iodine, they typically have a minus one charge. This is our rule. Okay, and but in bromine chloride, both bromine and chlorine cannot be negative. Okay, both elements are halogens, and but both element cannot be negative. So which one is negative and which one is positive? Keep in mind bromine. Keep in mind bromine has an electronegativity value 2.8, and chlorine has 3, and iodine has 2.5, and in this example, chlorine bears partial negative charge, and bromine is partially positive, because bromine has less electronegative than chlorine. Okay, so therefore chlorine is going to have its natural, and going to use its natural oxidation state minus 1. That means chlorine, the more electronegative element, uses their natural oxidation state, which is minus 1. And for bromine, we need to calculate it. Okay, for bromine, we have to calculate this oxidation number. And now, so it's going to be this equation is going to be bromine plus 3 chlorine, and that's equal to 0. And so our typical calculation, and our final result will be x is equal to plus 3. That means bromine, the oxidation state of bromine in bromine trichloride is plus 3. Okay, now our next example, which is iodine pentabromide, and for this equation, bromine is going to carry the partial, bromine is going to carry the negative charge. Okay, and iodine carries the positive charge. Okay, and because iodine has less electronegativity than bromine. Okay, and if we cannot remember this electronegativity value, it doesn't matter. Okay, because we know the periodic trend, as we move from up top to bottom in a periodic table, then the electronegativity decreases. Okay, and we know in group 17 chlorine comes first, then bromine, and then iodine. That's why chlorine has higher electronegativity, then bromine and iodine. And now, and another easy way, in any compound, usually the electropositive element is written first. Okay, iodine is written first. That means iodine is electropositive element. Electropositive elements are written first. The electronegative element is there in second. That means iodine is more electropositive than bromine. And so in this case, bromine is going to have its natural oxidation state, which is -1. And suppose the oxidation number of iodine is X. And our manual calculation, and this typical from this typical calculation, we get X is equal to +5. That means the oxidation state of iodine in iodine pentabromide is +1. But the bromine use their natural oxidation state -1. And so hopefully you understand the relationship between electronegativity and oxidation number. And now you will be able to calculate the find out the oxidation number in any compound. Okay, oxidation number of each elements of in any compound. And that's all for today, students. Assalamu alaikum.